Now that we know the concept of linear approximation from previous videos, we're going to use linear approximation to evaluate numbers we couldn't typically do without a calculator. Sometimes we'll be given the value of a number we should be able to plug in our head that is near the value we want. Other times we're going to have to come up with a ourselves. So first example we have here is evaluating the square root of x. We're going to use 144, a square root we should know, to approximate the square root of 146. So we're going to do our 3 parts to plugging in to linear approximation. Our first part is to plug in the value we know. So f of 144, our function is the square root. So we're going to take the square root of 144, which is 12. We've evaluated in the function. Our next step is to evaluate in the derivative. So step 2, we're going to take the derivative at 144. So starting with our derivative, we know that the square root of x is really x to the 1/2. So when we take the derivative, we'll bring down the 1/2 and subtract 1 for the new power. So 1/2 x to the negative 1/2. That's not written in a way that makes it easy for me to plug into my head. So I'm going to rewrite this so that I can do it without a calculator. So I have 1/2. I'm going to move the negative exponent in the denominator so that it makes it a positive 1/2. And we know that the 1/2 power is really the square root. So I'm really doing 1 over 2 square root of x, which makes it possible to plug in f prime of 144 in my head. It's going to be 1 over 2 times the square root of 144, which is 12. So the derivative at 144 is 1 over 2 times 12, which is 1 over 24. So we have the 2 pieces that we need in order to write our equation, which is the last step. The equation is always plugging into L of x. You plug in the value you know, plus the derivative at the value you know, times x minus a. So we're going to take these numbers and put in what we've got here. So our L of x would be f of a, which was 12, plus f prime of a, which is 1 over 24, times x minus a. And what's wrong with that? What do we need to fix? So sometimes we get a little confused and twisted up in this. We figured out 12 and 1 over 24, and then we go to plug it in, and we're missing one piece. It's usually the simplest thing that throws people off. You need to also plug in a here. So x minus 144. Should not be left with any a's in this equation. So we have x minus 144 here, because that is our value for a. And now we're going to use this linear approximation to actually answer the question. So it says find the linearization. That's what we just did. Here's our linearization. And we're going to use it to evaluate this f of 146. It's approximately going to be the same thing as L of 146. So plugging in 146 this, we get 12 plus 1 over 24 times 146 minus 144. So we have 12 plus 1 over 24 times 2. So we get 12 and 2 24ths are 12, and 1/12 is the same as 2 over 24. And you could leave it just like that, 12 and 1/12, or 12 and 2 over 24. Or you might know this decimal in your head. It's 12.083 repeating. It's okay if you don't know that decimal. We could just leave it as 12 and 1/12 if we didn't know it in our heads.